I believe you are all doing fine. My name is Steven Slumbo. Welcome to Environmental Science. We are going to look at fluid pressure in particular. This is the first series of pressure discussions, the fluid pressure discussions. We are going to start with static pressure. After this, then we'll be looking at dynamic pressure, that is pressure in motion for the fluid. This lesson is important to those who are studying towards the IVQ C&Qs Technician Diploma in Construction. So environmental science is one of the components that you take under environmental science and construction technology. In fact, we have three components in the environmental science and construction technology 3. That is, you have building services, you also have the construction technology and environmental science. So environmental science, today we'll be looking at the fluid pressure, particularly with the statics pressure, the pressure of fluid when it is stationary. So like I said, that we'll be looking at the fluid at rest or static. So a fluid is a substance that is free to move or to flow. That is, if we want to define what a fluid is any substance that can flow. Like gases and liquids are fluids. So any fluid will have the pressure. So pressure is the force divided by the area on which the perpendicular force is acting. For example, if we look at an illustration below where we have a coin in water which experiences the pressure by the weight or the force of the water on it. As you see on this container is filled with water up to that level, and then we have this symbol is representing the water pressure acting on the surface of this coin. So the coin is in the orange color. So that indicates the pressure of the fluids. But normally today we are looking at the pressure of a liquid. So how do we calculate the pressure of the fluid? Of course, the pressure of a fluid can be calculated using the density, acceleration due to gravity, and also the depth of the fluid. Like in this case, you are concentrating on you look at the depth of this fluid. So the depth of this fluid multiplied by its density and also acceleration due to gravity, then will determine the pressure at that point. So we want to derive a formula where we can work out the pressure of a fluid using this formula, because we normally know that pressure is equal to force over area. That's what we've learned earlier on. We've learned that pressure is force over area. But now how do we come up with this formula if starting from the force over area? And we have this container is filled with water, and we also have the force acting on that coin. Now we would want to determine the pressure at this point at the surface of the coin. So this coin have a column of water that is above it with a height h. Okay, so a height h, it could be in centimeters, it could be in meters, it could be anything, but whenever we are working out the pressure, it has to be converted to meters. So we have the column height above this coin is represented by the letter h, and also the surface area of this coin on which the water is acting is represented by the letter a. So that force will act on that, and So the force acting on this coin, the weight of water, or maybe the force of water above the coin, will have the weight W, or they will say the force F. So F is the weight of the column height on top of the coin. But then F is the same as multiplying, since we are saying F is equal to the weight. Therefore, weight is equal to mass times acceleration due to gravity, where m is the mass, that is m times that, where m is the mass of the object, the mass of the water in kilogram, and g is the gravity in meters per second squared. And then we move on to work out, since we've said instead of what we have here, we have f over a, so we are substituting mg for f in this formula. So that's what we have here, and we have pressure is equal to mg over area, where in this case f is equal to mg, or mg is equal to f. And next we would need to replace m in this equation. So we can replace m. We know that m from the density formula, where we say density is equal to mass over volume. So if we want to make m the subject of the formula, then we have m is equal to density times volume. So instead of having mass in this equation, we are going to substitute PV, that is rho V, for m. So we have rho and V and G over A. But then we can also eliminate this V, because we know that the volume is the same as the area, that is the area of the base times the height of the column. That is, if we go back to the slide, so that's the way we had this. That is, when we want to determine the volume of water on this coin, the volume of water above this coin, then it's going to be the surface area of this coin times the column of the water up to the top, which is h. So it's a times the column of water, as what we have in this. So that we have instead of having v, we have av. So av has replaced v in the equation. Now we can do our cancellation, since we have a, and so we have a there. So it's this a into a is 1, a into that a is 1. So we are remaining with p, that is pressure is equal to rho h g, or pressure is equal to density times height and times g. So that's in that case we have proved the formula to say pressure is equal to density times acceleration due to gravity, and then times the height. And the pressure is supposed to be in pascals, as it is in this case, and if the density is in kilograms per square per cubic meter. So density has to be in kilograms per cubic meter, and acceleration due to gravity has to be in meters per second squared, and the h is supposed to be in meters. Then the units for pressure is in pascals. So the pascal is the SI unit for pressure, and 1 pascal is equivalent to 1 Newton per square meter. And now let's consider measuring pressure. Today we are going to consider measuring pressure using the manometer. Of course, we are going to continue from here. That is, after we've done this, we will be looking at other methods of measuring pressure, like the bidon gauge, like barometer. There are several methods that we can use to measure pressure. So today we just introduced you to the manometer. So this is a manometer. It's a YouTube as it is, As you can see on this side is exposed to the atmosphere, so the atmospheric pressure will be acting on this liquid. So this could be any liquid, it could be water, it could be mercury, any liquid that you may use that will be convenient to use. So sometimes mercury may be a convenient liquid because it has got a higher density, which means that for maybe a bigger pressure you have the little column difference in column. But if we use like water, it may have a bigger column in the in this YouTube. So this arrow indicates the pressure that is being measured, and this has been connected to a gas, possibly where you could have the scale, and or you could have a gas to a certain pressure. So you have the liquid is at level A, and also there is at level C. So if we want to measure pressure, we normally work out this the height. As for the height, this is the mercury pressure, assuming we have the mercury in this. So assuming the difference, assuming the H is maybe 25 millimeter. So you say pressure is 25 millimeter on the mercury, that is 25 Hg. That is you give the Hgm, you give you give the chemical symbol for the liquid. That is if it is water, if you have used water, and then you have the difference, which is 25 millimeter, then you say 25 millimeter on the water scale, or 25 millimeter is 2. That's how it's normally done. But the explanation will be continued in our next slide, where I will explain in detail how the manometer works and the other instruments that are used to measure pressure. All those will be discussed in detail in the next discussion that I'll